All right, so in this video, the last of these three videos, we're going to go over dividing complex numbers, okay? So again, a complex number of the form a plus bi. So in the end here, our answers are going to need to be in this form. That's one thing you need to take into account. Remember, a and b real numbers. A is the real part, b is the imaginary part of the complex number. And again, we're going to have to use the fact that I squared equals -1 in the simplifying process, okay? So to divide two complex numbers, okay, to simplify or find that quotient, you need to multiply both numerator and denominator of the given problem, okay, by the complex conjugate of the denominator. Now, we've used this concept several times this year, but I'll go ahead and define it for you anyway, okay? After you've used the complex conjugate, you're going to need to simplify, and we want to leave your answer again as a complex number in the form a plus bi, okay? So given the complex number, let's just use one like 1 plus 6i. The complex conjugate, we're just going to change that sign in the middle, just like we've done before with some other concepts, okay? So 1 minus 6i. All right, again, remember the real part, the 1 stays the same. The 6i, the complex conjugate is going to have a different sign, -6i. And you'll see why that needs to be the case as we go through the process. All right, number 1 here. So the complex conjugate is going to be 1 plus 2i. All right, so I'm going to multiply both top and bottom by that complex conjugate of 1 plus 2i. All right, so in the numerator, I've got a binomial times a binomial. Nothing's going to cancel out. So I get 3 plus 6i plus 5i plus 10i squared. Okay, that's my numerator. In my denominator, I've gone ahead and shown this, but remember, these are the sum and difference of two terms here. The middle two terms should always cancel out. The 2i and the -2i are always going to be opposites. That's why we multiply by the complex conjugate. Okay, so 1 times 1 is 1. -2i times 2i is -4i squared. And then these two terms cancel out. All right, so in the numerator, when I simplify, remember this, we're going to plug in -1 for I squared, so this becomes a -10. So 3 minus 10 is -7. And then I combine the like terms for the i's, so that's going to be where the 11i comes from. Okay. In the denominator, again, these two canceled out. I plugged in -1 for I squared, so -1 times -4 is +4, and +4 times the 1 that was out front gives me the 5. Okay. Now, when we were solving like quadratic equations before, we might have left an answer like this, okay? But for now, remember, we want to be in the form a plus bi. So I need to break this into two parts, okay? So my real part is going to be -7 over 5, and my imaginary part is going to be 11i over 5. So this gives me the form a plus b, which is 11/5 times I, okay? So that's how you divide two complex numbers, all right? Pause the video, give 2 a try, and then come back. All right, so I'm going to multiply by my complex conjugate, which is 1 minus 6i, all right? I've got a binomial times a binomial in the numerator, and remember in the denominator, again, I'm going to show you this, but those should always cancel out. So check your numerator, -7 plus 42i minus 3i plus 18i squared. And again, in the denominator, you should only have 1 minus this 36i squared. There's no reason to show this step, but I just want you to see it. Okay, so when I plug in -1 for I squared, simplify, I should get the following. Okay, -25 plus 39i over 37. And now we want to write that as a complex number like we did here in the form a plus bi. And I get -25 over 37 plus 39i over 37. Okay, all right, one more, looks a little bit different. Okay, we got number 3 here. Notice my denominator is just the imaginary part of the complex number. There's no real part, there's no a value here. Okay, so what do you think the complex conjugate would be in a situation like this? Okay, so I'm going to multiply by the complex conjugate, which I hope you guessed was -4i. Okay, we want this to be negative, and you'll see why in a second. We want it to be the opposite, in this case 4i, in this case -4i. All right, so just going to distribute up here in the numerator. That gives me a -20i minus 12i squared over -16i squared. Okay, and you'll see here when I evaluate the denominator here, it's going to give me a positive number, and I always want my denominator to be positive. So that's why we want to make sure these signs are opposite. If I were to use the same term, 4i, okay, then I'm going to end up with a negative value in the denominator. This is going to add an extra step of work. Okay, so let's simplify the numerator. That's going to give me a positive 12 minus 20i over 16. Let's write this in the form a plus bi. Let's simplify. 12 over 16 simplifies to 3/4. And negative 20 over 16 simplifies to negative 5/4 I. Okay? So that's how you divide complex numbers. Use the complex conjugate, simplify, and then make sure your answer's in the form of a complex number.